Linear perspective, one-point perspective. Drawing a box in one-point perspective. Start by drawing a horizon line and marking the vanishing point. I like to use an X to be as precise as possible. Sometimes a point is either too small to see or too big to be an actual point. Now, draw the front face of the form you want to draw. In this case, it will be a rectangle or a square since we'll be drawing a box. Once the rectangle is drawn, you will have created 4 points or corners of the box. These corners will be the beginning of the sides of the box as they recede back in space. From each of these points, draw a line back to the vanishing point. These lines that are parallel in real life, but in your drawing will converge at the vanishing point, are called orthogonals. Now you've got a box that goes on forever and disappears behind the horizon line. In addition to the front face of the box you started with, there is now a bottom, top, left, and right side of the box. Next, you'll determine the box's depth by drawing the back of the box somewhere on these orthogonal lines. Do this by drawing a vertical line that corresponds to the front left side of the box. This can really be done with any of the sides, but this one is easy to see in this example. From here, you can complete the back plane of the box with a series of perpendicular horizontals and verticals. After erasing the leftover trace lines, you'll have a completed box. Currently, this box shows the form as if it were transparent. Here's what it would look like if it were solid. With all of the lines of a transparent form showing, it can become confusing which lines are the closer and farther ones. Put another way, it might be difficult to remember which is the front of the box and which is the back. In linear perspective, the larger plane or side will always be the closer one. Even if you know this, it can be helpful to add some line variation. Showing thicker lines in the front and thinner lines in the back will help this effect tremendously. This box was drawn above the horizon line, which is the same as your eye level, so we're looking up at it from the bottom and not seeing the top at all. If a box were drawn below the horizon line, you would see the reverse, looking down on the box from the top instead of the bottom. Placing the box to the right of the vanishing point instead of the left would cause us to see different sides of the box as well. Here's a drawing using these same concepts. You can see the horizon line is placed high on the page, so this box will be drawn underneath it, as if we're looking down on it. The vanishing point is placed on the horizon line on the left-hand side. I'm starting with the front face of the form, a rectangle in this case, then drawing the lines for all 4 corners of the rectangle back to the vanishing point. Determining how deep I want the box to be, I'll draw a second rectangle at that distance to correspond to the first. The hardest part of this whole process is probably keeping all of the lines perpendicular. As often as possible, I use the edges of my right triangle ruler lined up with either the edge of the page or the horizon line to ensure they aren't crooked. Finally, erase all of the extra trace lines that don't contribute to the form of the box. A solid finished box would need even fewer of these lines to be considered complete. But I draw all boxes as if they are transparent because this is the form they need to be in to be modified later. Often in a drawing, the box is just the starting point or the scaffolding for a more complex form. Finding halfway in perspective. You can find the center of a box, or halfway, fairly easily in perspective. First, let's set perspective aside and deal with the front of the box, which is flat and not in perspective at all. You can find the center point by drawing an X, and you can divide it in half vertically or horizontally by drawing straight lines through the center of that point. You could divide it evenly again and again and again this way. Finding the center of a plane in perspective works almost the same way. Create an X by connecting the four corners of the plane you want to divide. Then, since it's a plane with horizontals, the horizontal halfway will be the same, parallel to the other horizontal lines. Draw a line that goes through the center point and back to the vanishing point. Here on the side plane of the box, the vertical line will remain the same, parallel to the other verticals. The horizontal will instead be an orthogonal, going back to the vanishing point. You can find the center of the entire box by connecting opposite corners of the box to one another. Once you've drawn a box, you can modify it in many ways. Create a wedge by dividing the box diagonally and choosing either the top half or the bottom half to preserve as the form. You can create a triangular prism by finding halfway on the front face of the box, converting it to a triangle, and then connecting the 3 points of the triangle back to the vanishing point. Look at where the orthogonals intersect with the back side of the box. Ending your trace lines here will keep the triangular prism the same size as the original box. The diagonals that you see being drawn to complete the box have nothing to do with linear perspective. They are simply lines drawn with angles that correspond to the angles of the triangle on the front plane of the box. Finally, here's a wedge drawn to slope back in space. Another way of modifying your form is to cut out of it and add on to it. To add on, start by modifying the front plane of the box. From there, the steps are a lot like drawing another box. Connect all of the new points you've created back to the vanishing point. You'll have to decide whether to terminate the second box at the same point as the first box, before, or past it. I chose to terminate the box before the other box ended. Cutting into the box is a little different. Again, start by modifying the front plane. Connect all of the new points you've created back to the vanishing point. From there, you have the option to first cut the whole way through the box, or second, end this cutout before the box ends, giving your cutout a back plane. If this box were solid and not transparent, here are some of the lines that would not be seen. This was a complex process, so here it is again as I draw it on paper. One difference you may notice is that this form is drawn much closer to the horizon line, and that the box that's being added on now is actually passing over the horizon line. So some orthogonals will be traveling down to meet the horizon line and the vanishing point, while others are traveling up. Planes. Each side of a box is considered a plane. Understanding how to create these can be helpful. While the front and back plane of the box are not acted on at all in perspective, all other sides of the box will appear foreshortened, meaning their proportions will seem distorted as they travel back in space. So let's look at one of the vertical sides of the box. To create this plane, start with a vertical line. Draw lines back to the vanishing point and then end it with another vertical line. For the horizontal planes, it's a similar process. Just start with a horizontal line, again connect lines back to the vanishing point, and end with a horizontal line. Ellipses, cones, and cylinders. Just as the rectangle appears foreshortened when it travels back in space, so does the circle. A circle, when foreshortened, is called an ellipse. To properly visualize the way an ellipse should look, start with a rectangle of any proportion. Remember, if you start with a square, you will just have a circle. Then locate halfway on the rectangle. The 4 points where the division lines touch the rectangle will be the points where the ellipse should touch. Avoid making almonds where the ellipse comes to a point, and hot dogs where the ellipse flattens out against the rectangle. Here are several ellipses represented with varying degrees of foreshortening. So to draw an ellipse in 1 point perspective, start with a plane. Use an X to help you divide the plane evenly in half, and then draw a smooth ellipse. Try to be light and loose with these marks, and then get darker as you become more confident in the integrity of the ellipse. Once you understand ellipses, you can create a cone. Extend a line out from the center point. Determine the height of the cone on this line and connect the outermost edges of the ellipse to that point. A sense of volume may not be fully achieved until the form is shaded. By the way, pyramids can be created with a very similar process. Draw a plane, find the center point on that plane. Next, draw a perpendicular line projecting out from that center point to define the height of the pyramid. Then, draw a line from that point to each of the corners of the plane. Here is that process playing out again in the plane on the left. And here are the pyramids with their planes shaded in to show a light source and reflect a solid form. Ellipses will also help you make cylinders. You'll start with a box. Here I'm starting with longer boxes to give a sense of the length of the cylinder that I'll be building within them. Start by drawing ellipses on the 2 opposing smaller planes, and finish the cylinder by connecting the ellipses. For these 2 boxes, the lines that connect the ellipses will be parallel. Starting outside of the box, slide your ruler in. The first point you hit on the ellipses is where the exterior lines of the cylinder should go. If your ellipses don't line up perfectly, this is an opportunity to reconcile that. For the cylinder whose parallel lines are traveling back in space, these lines will be orthogonals. This time you'll need to line your ruler up with the vanishing point and rotate it up or down until it hits the outside edges of the ellipse. This will indicate where the sides will go.